Hey guys, we are on week 3 of our magic box. If you didn't know, this is the last week, so kind of sad, but at the same time, kind of exciting. I gave a little bit of a sneak peek last time, so what we're going to do is we're going to add an ultrasonic sensor to our wonderful box here, so that when we come up to it, without touching it, it's gonna open. All right, so let's go ahead and get started. So here is our ultrasonic sensor. I want to point out a few things here. All right, we have 4 pins that you see here, and I'm going to turn it so you can see it. It says GND, Echo, Trig, and VCC. Okay, those are the 4 pins that we're going to have to connect to our Arduino noggin. But before we do that, I want to talk a little bit about how this thing works. Okay, so let's talk a little bit about a bat. Okay, I'm going to draw a bat here. Here's my bat. Okay, now my bat, you may know this already. The bat actually cannot really see the way that we see, right? It's actually blind. So the way that it sees is through sound. All right, so I'm going to put over here. All right, this right here is a wall. Now the bat is trying not to hit the wall, right? So this is what happens. The bat makes a sound, okay? And it hits the wall, and what's going to happen when it hits the wall, it's going to create something you might already know. It's called an echo, and it's going to bounce back. And once it bounces back, the bat starts to think, okay? That's my little think bubble. And I'll put here plus, minus, divide, x. All right, let me make sure you can see that. So this is supposed to represent math, okay? So he's trying to do some math. And then inside, then the bat is able to see from here to here, which is distance. All right? So that's what's going on here. The bat makes a sound, it bounces off the wall, and then he does some math in here, and then that gives distance. So that's how echolocation works. We're going to learn about that today, and let's now relate it to this guy here. All right. So if you remember, our ultrasonic sensor has 4 signals. So let's go ahead and figure out how we're going to wire up our ultrasonic sensor so that we can do all that. Okay, I got my ultrasonic sensor here. Remember, we got 4 signals: VCC, Trig, Echo, and GND. Okay, so I'm going to draw this will be our noggin. Okay, now we have stuff connected to this already. I'm going to leave it off this diagram so that it doesn't confuse us. Go ahead and draw our ultrasonic sensor. 1, 2, 3, 4. And then I'm going to look at this, make sure I have it right here. This one here, VCC. This one here is, I'm going to put T for trig. Then here is E for echo. And then G, then D. Okay? So now we got to figure out how to connect this to our noggin. If you remember, the noggin is going to be the brain. So remember, going back to here, okay, we had the bat needed to do some brain power, okay? So if that's the case, that means this needs to be the brain, okay? So here we go. This is your brain. Okay, let's make some connections here. So VCC, that's going to be connected to 5 volts. Okay. The GND is connected to GND on the noggin. All right, GND to GND, VCC to 5V. Okay, easy enough. Just so you remember, from the very first lesson about electronics, 5V is the plus, and GND is the minus. Okay? If we don't have a plus and a minus, it can't get power. So what this establishes here is that if we connect VCC to here, GND to here, our sensor now has power. So that's good. But now how do we still need more than just powering it up. We need to be able to talk to it. So there's 2 things, trigger and echo. Okay. Going back to this guy. Echo is going to be the one coming back here. Okay, so this will be echo. Now, the opposite of echo would be trigger, which is you're sending something out or pulling the trigger kind of thing. So the bat is pulling the trigger on his sound, so it's sending it out. So when it comes out, it's going to be trigger. Okay? Trigger going out, echo coming in. All right, so now that we have that, we kind of know how this works. Let's go back here. Trigger is actually going to be pin number 3. All right, pin number 3. When we start coding, this will be important, okay? Pin number 3 is trigger. Actually, when we start wiring too. So wiring and coding, we got to know. Trigger is 3. Echo is going to be number 4. Okay? Pin number 3 is trigger. Echo is 4. Now, before we start coding and then wiring, I want to kind of give you a little brain exercise. If you remember, our robot brain, our noggin, can have inputs or outputs. I want you to think, is pin 3 an input or an output? Let's see. Well, pin 3 is going to be connected to a trigger. Going back to here, our trigger, is it sending out from the brain or is it getting something in from the brain? Well, from the picture, trigger is coming out from the bat, which is in the brain's on the bat. So trigger should be output. Okay, now let's look at number 4. What is pin number 4? Input or output? If you look over here, it comes in because it is echo. Echo comes into the brain. So 4 should be input. All right. Number 3, output. 4, input. So that's going to come into play when we start coding. I want to give you a little taste of what's coming, and it's good to kind of like prepare our brains so that we better know, so it's easier for us to know what we're doing when we're starting the code. Okay, so I'm jumping around a little bit. Let me come back. So now that we kind of have some context of input and output for 3 and 4, let's first wire our robot, and then we can go from there. All right, guys, here we go. Now we're going to go ahead and wire up our ultrasonic sensor. Here's our breadboard. Now, we haven't had a lot of time to go into the breadboard, but let me just explain briefly how this thing works, okay? So I'm just going to take this little wire here to help me explain how this works. First, you got to make sure your breadboard is up and down like this. So that's vertical, so not like that. That would be horizontal. I want to make sure it's vertical. And then what you do is you just keep this in mind. If I put a wire or anything into a hole like this, all right, I have to see what row is it on. Well, this is on the top row. So all these holes, these 1, 2, 3, 4, there's these 4 holes here that are on the same row. If I put another wire on that same row, those two holes, or these two wires, they're now connected. So that's what the breadboard does. It helps us connect wires together. So right now, black and green, they are connected. If I move the green to like a different row, see this one's like on the 4th row, those are no longer connected. Okay, so that's all we need to know. There's two sets of rows. There's two sets of rows. There are all these rows right here, and then there's some on this side. Okay, let's not worry about that side for this project. We're just going to need one side. Okay, so don't even worry about that side over there. All right, so now we have that. Let's go ahead. We're going to take our sensor here, and here's what you got to do. There's these 4 pins here. You have to put it onto your breadboard so that all 4 pins are on different rows. So let's think about that. Now the rows, like I said, they're like this way. Okay, so here's row 1, row 2, row 3, row 4, like that. So what I need to do is do it like this. Okay, if I do it that way, then all the pins are on its own row. Just to be clear, if I do it this way, you see all the pins are on the same row. So if I do that, all my pins are actually all connected together because they're on the same row on the breadboard. So that's not good. That's not what we want. Let me take it off. We want to make it like something like that, all on different rows. All right. Now I'm going to turn it this way so you can see what's going on. So now I'm going to take it horizontal. So once you have it, your ultrasonic sensor in, now let's turn it horizontal so you can see all the signals. And you can see VCC. Here, let me get a little pointer here. You have VCC, trig, echo, and GND. So let's go ahead and make those connections. So first thing I want you to do is take a black wire, okay, and connect it to the GND. There, okay. So it's on the same, see that? It's on the same row as the GND. So that's connected. Now take this side, and what you're going to do is connect it to the GND on the noggin. The GND on the noggin, I think there's one right here. All right, nice, okay. So that's on the GND of the noggin. Now let's take a red wire and connect it to 5V, sorry, not 5V, VCC on the breadboard. So VCC you see is like right here. So you got to put it on any of these holes on the same row. Okay, so I'm going to put it right there. Okay, let me turn it so you can see. See, it's on the same row. Okay, now this side, let's go ahead and put it on the noggin. And I need to put it into 5V. 5V, where is 5V? Right here. Okay, so we're looking good. Now there's 2 more. We have echo and trig. Let's take a yellow wire and put it into the echo row. It's this one. Okay, and echo is in pin number. I'm just looking at my drawing here, my diagram. Echo needs to go to pin number 4. So it's over here. Here's 4. Okay. All right, and then last one, echo trigger is the last one actually. Trigger. So it's gonna be the last row that we haven't put anything in. So let's put the green one, and then that's gonna go into pin number 3. So that's right here. Number 3. All right. So now we have it wired up. Here's our little guy. Looks kind of cute, like Wally. All right. And now we're ready to start coding. All right, guys, we are ready to start coding. So let's look at what we got here. We have our magic box. I went ahead and stuck the breadboard on the side here so that it can, we can mount our little ultrasonic sensor. If you're not sure how to do that, the back, there's a little sticky foam underneath. So let me show you. You can kind of see like the white. And if you look carefully, there's a white sticky foam under there. That's what I ripped off this, not ripped, but peeled off this yellow paper. And then I could stick that on, okay? So go ahead and mount it somewhere. You just make sure you don't put it like on top of here because it would like fly up whenever opened. That's not what we want, right? So probably either this side or on this side. That would work too. All right, so I have my noggin, okay? And I have a USB cable. Mine is black here. Yours is probably blue. Either way is cool. All right, and I'm connected to my computer. All right, so looking at my computer here, let's go ahead and set up all the stuff we need to start programming. So we go to Tools, we go to Board, and we want to make sure we have Arduino Nano. The processor, we want to make sure we have this old bootloader one. And then the port, you got to make sure it's either it's a COM. If you have one of our classroom computers, like in class, there's sometimes a COM1 and COM something else. The rule for our classroom computers is that it can't be COM1. So COM3, COM4, or whatever, that's probably the one that will work. If you're using a Chromebook or a Mac, this COM is going to look different. So if you need instruction on that, I encourage you to check out the Getting Started Connecting, or it's called Connecting Hardware videos, tutorial videos. So if you need to find those are on our website under the resources. So that's there in case you need it. Okay, so now that we have it all hooked up, let's go ahead and make my box open. So at this point you need to remember, okay, so what numbers did I put in order to make my box open? Yours might be different from mine. So I remember when I went to start making this thing, my angle was 90 to make it open. Okay, so I'm going to put 90 for the angle. Pin 9 is correct. Okay, so now I'm going to upload. And my box should open once it finishes uploading. Beautiful. It totally opened. Awesome. All right, so then now let's close it by going angle 0. And it will close right now. Beautiful. All right, so it's open and it's closed. So now let's start playing with this ultrasonic sensor thing. All right, so this is how you do it. All right, so we're gonna do something called serial print. So I want you to go to Communications, and I want you to go to serial print. Okay, and then you're gonna go here to Barnabas Robotics and grab the ultrasonic. There's 2 of them here, ultrasonic, ultrasonic ping. You don't want the ping one, just this one, okay? Just ignore this guy for now. Okay, ultrasonic, this one. Now you see I already put trigger is number 3, echo is number 4. That's where we wired. Remember on the breadboard over here, we wired 3 to trigger, echo to 4. It's like automatic for you. So lucky you, I did that for you. If it doesn't say 3 and 4 here, you better fix that. Otherwise, it won't work. All right, so what we're going to do now is we need to connect ultrasonic to this serial print thing. Serial print's actually going to print a message to your computer screen, and then you can see what the ultrasonic is seeing. Now, I see a problem. This thing does not click, and what's going on, right? Well, we need a special connector. So let's go to Communication, and you see glue. There's 2 of these. Which one do we need? Which special connector will allow us to connect to ultrasonic? This one. Boom, boom. All right, so now, you know what, I'm going to get rid of this just so it doesn't confuse us. Okay, so now we're just going to make a program. It's going to print the distance, whatever it sees on ultrasonic, it's going to print it on the screen. Okay, so watch this. I'm going to upload. And then in a few seconds, or right now, we should be able to see what's on the screen. Do you see anything? No, we do not see anything. Don't worry, because we have to do something. We have to click here. It says serial monitor.
let's click here, and then check it out. Now I see something. Okay, I'm gonna kind of size this guy up. Let's move it over. Okay, do you see it saying message 43 blah blah blah, right? Because look, it's saying message here, and then it's gluing this, whatever is coming out of ultrasonic, to message. So it says message and then 43. So ultrasonic is saying 43 right now. Now check this out. Okay, I'm gonna bring this light coaster thing, and I want to go. Watch what happens when I cover it. Look, it's like 4 now. If I go all the way up to it, it's like look, it's like smaller, and if I go further away, it gets larger. So it's actually telling you the distance, the number. Now, what unit do you think it is? What I mean by that, guys, when it says right here, like 5 or 6 or 7, say 7 or 6, what is it, 6 centimeters? 6 meters? 6 miles? 6 kilometers? Like, what is this distance actually? Well, it's actually 6 centimeters. So the distance is in centimeters, okay? All right. So now we know that's working. Let's change the message, because I don't want it to say message with a number. I want it to say like distance. So I'm going to go here. Instead of message, just say distance equals. Okay? And then we'll upload. All right. I'm going to come here to bring back. So remember, you're probably like, where's the message? I don't see. Click here. Now it says distance equals 40 or whatever. And if I go closer, distance equals 6. Okay. So this is pretty cool. Our robot, that was pretty easy, right? Now we know the ultrasonic sensor is working. And just a reminder, what's happening is the sensor sending out some sounds, and then it's bouncing back. It's bouncing off objects, like it's bouncing off this coaster right now, and then it's going back into the receiver or through the echo. Okay, so how do we get it to say, if something comes close to me, open the box? How do we do that? Glad you asked. Well, it's actually not that hard. We have to just like talk it out, right? If something, open the box. So let's see if we can do that. I'm going to first move this serial print thing. We don't need that right now. Okay, I'm going to move it here. Let's go to control, and let's get this guy. If/else. All right, now I'm just going to talk it through, just like I'm trying to tell my robot what to do, and you'll see actually it's all going to make sense. Okay, so if something, do open the box. All right, so let's say the something part. What is the something? Well, we want to say if the distance is like small, right? If I'm really close to it, I want you to open. If I'm really far, I want you to not open, right? Okay, so if I'm close, open up. How are we going to do that? All right, watch this. Go to tests, and I'm going to pick this guy right here. Okay, it's a less than sign. All right, and watch this. I'm going to move this out. I'm going to move that out. Throw that in there. Check it out. Check out what it's trying to say. If my ultrasonic says something less than what? I'm going to say if it's less than 5, because 5 is when like I'm really close. Okay? So I'm going to say if it's less than 5, then open. So I'm going to go to variables and constants and get this number 1 here. And I'm going to say change it to 5. So if the distance is less than 5, then open. Right here I got to put code to open. If I remember, go to pins, servo. Okay, you could also find it here. Either one, okay? They're the same. Got servo 9, and angle to open was 90 for me. All right, so I'm saying if the distance is less than 5, open. Else, meaning like the distance is not less than 5, that means I'm far away, I want you to close the box. So how do I do that? Put in my servo and put in the code to close. To close the box. Shall we try? Yes, let's do this. Upload. Okay. Okay. Okay, it's not doing anything. But if I put my hand up to it, will it open? Will my magic box be done? It works. I put my hand up. Check it out. Now, you see how it's kind of like fidgety? It's kind of fidgety, so you can kind of play with the number. Like maybe 5 doesn't work as well. Maybe I'll put 10. Let's see how maybe it responds better if it's less than 10. Okay, so let's do this. I'm gonna get closer. Oh, see, that's more stable. Cool. Okay, this is so guys, we're basically done here. So all you have to do, guys, is plug in if you plug in your battery into this power jack right here, all right, your magic box, you'll be able to use your magic box without the USB cable. You just got to plug in the power right there. Let me make sure. Right here, okay? Right here. All right, so what could you do with this? Well, you know, this is time to be creative, you know. Think about what you could do with this thing. Now, one of the things that I always try in whenever I'm doing a little table with my robots, I have kids go like this. They have to open it, and then I'm gonna put something inside of the box, and then they have to take it out before the box closes. Take it out. Oh, take it out. Okay, see, you see, it's like impossible, right? So how can I make it so that it's not so impossible? Check this out. Let's look at our code. So what we want to do to make it more possible to take something out before it closes, we got to put a delay. We got to tell the box open, and then I want you to stay open for like some time and then close. So we're going to go to the code that opens the box. That's this 990 one for me. I'm going to add in, go to control. Let's put a delay 1000. So it's going to open, and it's going to stay open for 1000. And then after that, it's going to close after it loops through here. So let's try this. I think 1000 should be enough time for me to put something in there and take it out. Okay, so let's try this. See, now it stays 1. So what I can do is so this business card, let's put it in there. Okay, I have 1 second to get my business card out before it closes. Okay, that's still. Let's do it again. Okay, that actually, I guess I'm a lot slower than I thought. Okay, this is actually still impossible. I'm too slow. Maybe you guys are faster. I'm gonna be like the super old person mode, which is 5000. Okay, if I can't get my card out in 5000, which is 5 seconds, I am super slow. Okay, but let's see. Okay, take my time. Okay, that was like easy. I totally. Yeah, so you can see that is way too long. But maybe you need easy mode. It's 5,000. I'm gonna do like 2,500 for medium mode. I think this will be like kind of hard, but not impossible. Let's see. Open. Okay, so that worked. Let's see. Sometimes he... All right. There you go. All right, guys. So he's kind of happy right now, just kind of messing with me. All right, so guys, that's about it. Here's the point. So you got this basic code where you can play with the delays to see how often you want it to stay open. If you want it to make a game like how I made it, you can decide how hard you want to make it, right? Because if you make this time really low, it's going to be super hard, and if you make this really big, it'll be like the easiest game ever. So that's up to you. You guys can play with that. That's it for now. We are now done with our magic box. We're able to build a contraption so that it can mechanically open and close. We learned how to program servo motors, and we also learned how to integrate a sensor to it so that it can open. And now think about, what can you do with this box, right? Maybe it's something that you use during Halloween this year, right? So when people come up to it, it will open up on its own and there will be the candy. Maybe it's your own personal trash can. So, when you put your hand up to it, it opens so you can throw trash in it. Maybe you want to put some plastic lining, like a little trash bag that you could, take out, and then when you take the trash out, put a new lining in there. Or maybe you have some other idea. So I would love to hear what you guys end up doing with your magic box. I think there's just a million things that you can do that I haven't even thought of. So please do try it out. Keep me posted, like send me videos or pictures or whatever. I would just love to see you guys use your creativity in using your magic box. Hope you guys had fun. And I hope to do more of these classes in the future. So if you guys enjoyed it, let us know and we can do some more. All right, take care. Be safe out there. Bye.